So when we did this bridge experiment, they kind of asked you to make a prediction in the beginning, right? How do you think the length of the bridge is related to its strength? Now I need you to think back and tell me what you did before you started, because a lot of you kind of know the answer now, but how many people had check marked, you thought the longer the bridge, the more weight it could hold? Just be honest. Remember, you were making a prediction. Okay, so 3 groups, okay? How many people thought the shorter the bridge, the more weight it could hold? Okay. How many people thought it was the length of the bridge will not affect how much weight it can hold? Okay, so we kind of had a mix of everything, okay? So we'll see which one. Okay, this was kind of the most of us, and then kind of we're in the middle here in the middle. So I'll circle that one. That's kind of the most. So I'm gonna share the data that I had. It may be a little different from yours, but it's probably gonna end up kind of the same idea. All right. When I did it earlier, there was 23 pennies that broke the 4-inch bridge, 14 that broke the 6, then it went 9, 9, and 8. So yesterday, when we talked about a table, it was the turtles, right? The one table was going up a mile per hour, that one turtle. The other one was going 3 feet per second, like every. So what did those tables have that this table does not have? What did the tables have yesterday that this table doesn't seem to have? A what? Constant what? Yeah, there's no constant rate of change here, right? From here to here, it's -9. Then it's -5. Then it's 0. And then it's -1. So it's not changing by the same thing every time, right? So that's not a constant rate of change. So how that goes to the graph, and again, I've had people ask me this, like, how do you know how to graph the intervals? Well, our intervals were from 5 to 11, right? Or 4 to 11. Well, there's 1, 2, 3, 4, 5, 6 on the bottom. So if I go by 2s, I'll have 12 there, right? 12 will fit the length, right? Because this is bridge length. So this is 2, 4, 6. That's going to fit our 11 to 11, right? So 4 to 11 inches. And then the breaking weight, the strength, well, 23 was my highest. So if I go by 4s, I should be able to fit that, right? That's going to go all up to 24. And the highest number I had was 23. So let's say you went to 25 or 26, maybe you go by 5s or 6s. But that's how you want to try to be able to fit everything in. So at 4, 23. Well, that's 22, so it's right there. So I'm going to plot these points. All right, 6, 14. Right here. I just plot my data. Your data might look a little different, and that is okay. Oops. I gotta move this up to 9. Hold on. There we go. Okay. Now, the graphs yesterday for the turtles. What kind of lines did we have yesterday? For the turtles. What did the graphs look like on the turtles? Straight lines, right? Is that a straight line? No. I mean, it starts off going like a straight line, right? I mean, it comes down to here, but then it kind of goes this way, then it goes this way, and then it goes. So, yeah, that is not a linear line. Not even close. Okay? So, on the back side, describe the relationship between the bridge length and the breaking weight. How is that relationship shown by patterns in your table? Well, so when we describe the relationship, as the bridge length increases, okay, remember the bridge length increased, right? 4, then went to 6, and then 8, and then 9, and 11, right? What happened to the breaking weight? How many pennies did it take? Huh? Took less pennies. So the breaking weight did what? Decreases. Now we're not done here. We still got to be able to figure out one thing. It decreases at a non-constant rate of change. So in this sentence right now, you just basically told somebody who was ever reading this that this model is not linear. If it was like yesterday, you would say at a constant rate of change, because everything yesterday was a constant rate of change, correct? Okay. So this part right here, you just told them that basically this was nonlinear. Now, just from using my table, all right, so remember we had the bridge length and the breaking weight, because they wanted us to predict, right? 4, 6, 8, 9, and 11, and it was. So, for example, at 3 inches, well, 3 inches is above 4, right? So you probably picked some number that was above that number. Whether you went up 9, like this decreased by 9. So whether you went up by 9, up by 10, it's hard to kind of pick a pattern because there's no pattern to this. But most of you, I'm sure, kind of guessed some kind of a number bigger than what you started with, right? Your bridge breaking weight, right? Because the smaller the bridge, what should theoretically happen? The more pennies it should take, right? Now at 5, which is right in here, you probably had to pick some number between 23 and 14, or between whatever those two numbers are, right? Whether you went the middle or however you decide to do it, but you had to kind of find some range in there. Again, you don't really know the pattern, so in terms of what you could pick, it could be lots of different possibilities. 10, obviously, right here, and maybe for me, I'd say like 8.5 with the pattern, because there's really no, or maybe write 8 again, and then at 12, okay, how low is it going to go? The minimum we had 8, and maybe it goes down to 6. That bridge is getting longer, so that middle is getting really weak, right? For it to snap. Okay. So just some kind of method of thinking what we were looking for there in terms of how you were predicting. You want to write down for 12 inches like 37 pennies, because there's no way it's gonna be stronger than that 3-inch bridge. Okay. And then same thing up here. If you were able to hold 30 pennies, well, we know that at the 4-inch bridge it held 23. How long should the bridge be? How many people said like 3 inches? Or 2? It had to be basically smaller than what you started with, right? With 4. So you're looking for some number smaller than 4. Because there's no way it's going to be longer than 4, right? So you probably had to pick something kind of up in that 2 or 3 inch range. Again, just trying to see if you understood the lesson. So now to summarize. So yesterday, what kind of models did we look at? Linear ones, right? And they were linear because of what? Straight line, constant rate of change, right? Today, these are nonlinear because not a straight line, and this is a non-constant rate of change. Okay, the tables don't have any patterns. Remember, you always see the constant rate of change in a table. You can always tell the graph if it's linear or not by the straight line in a graph. So those two things can tell you if it's linear or non-linear. So this was obviously non-linear. Okay.